Starting in a wild, weed-filled wasteland, the expert ventures deep into the scrapyard. This damp terrain is the #1 enemy of electronic devices because it accelerates oxidation. Right under the dirt and rocks, he discovers a pair of third-generation Apple AirPods. Their current condition is absolutely terrible. Caked with dirt, mud has weathered the entire plastic surface. The outer shell has turned a severe rusty color. The level of damage shows the device has been buried underground for months. At the workbench, the rough cleaning process begins. He soaks the device in a water tray and adds cleaning powder. The cleaning powder creates a chemical reaction, combined with the friction from a soft bristled brush to peel away the clumps of mud. The scrubbing force is carefully controlled to avoid scratching the polycarbonate surface. Opening the case reveals a heavily rusted charging compartment. A stiff bristled brush is used to scrub deep into the narrowest charging contact slots inside. The murky washing water is filled with metal shavings and dirt. After drying the case, he proceeds to treat the 2 earbuds. The stubborn dirt clinging to the speaker mesh is knocked loose. Next, the components are soaked in a specialized rust removal solution. This yellow solution will quickly neutralize the stubborn oxidation layers on the metal contacts. The micro-sanding process begins with fine sandpaper. The friction removes the yellow stains embedded deep in the plastic. This technique requires great finesse to avoid damaging the molded Apple frame. Every metal edge under the charging port is also polished. Entering the complex hardware dissection phase, the technician lifts the circuit board and battery assembly out of the case. Rust has completely corroded the motherboard. Using tweezers to pry into the gasket to separate the shell, protecting the speaker membrane. The pulse soldering station is turned on. The high-temperature soldering iron quickly melts the solder to separate the microchips. Using anti-static tweezers, he carefully extracts the speaker assembly core and cylindrical battery from the earbud shell. The microscopic structure requires absolute precision, so as not to tear the fragile, flexible ribbon cable. Moving on to the charging module, a flathead screwdriver is used as a lever to gently pry apart the structural plastic frame. The motherboard assembly is revealed, along with SMD capacitors and power ICs that have been corroded by rust. The expert sequentially extracts the copper contact pins from the severely degraded charging slots of the case. The soldering iron is used again to desolder the lead joints, detaching the ultrafine copper cable from the cylindrical battery. The entire empty polycarbonate plastic shell is gathered together, preparing for the intensive surface restoration step. Industrial cleaning chemicals are once again dissolved, whipped into a strong foam to optimize surface tension. 5 brushes and sweeps alternately scrub continuously. penetrating every nook and cranny of the mechanical hinge. A beveled steel pick is used to scrape away the stubborn deposits. Stuck deep inside the earbud's sound funnel. This is a sensitive area that determines the acoustic resonance of the speaker chamber, requiring thorough cleaning. A close-up dissection of the speaker driver assembly. The microsurgical tweezers pry delicately to peel away the biocellulose vibrating membrane. The voice coil and neodymium magnet are completely ruined, even though this is the heart of reproducing spatial audio. Placing the charging microchip onto a universal holding clamp. A thin layer of flux paste is applied to the IC pins. The emitted heat combined with the soldering iron smoothly melts the old solder, restoring the copper pads that transmit charging signals. The washed shell is rinsed again with clean water. Ultra-fine grit wet sandpaper is put to work. Each steady, rhythmic stroke shaves off a few microns, restoring the denatured plastic to its original bright white. The rounded corners of the AirPods 3 are subjected to strictly controlled friction to avoid losing their aerodynamic shape. Preparing for the painting step, a hot glue gun securely fastens each plastic shell piece to long, thin zinc rods. A foam mounting system is set up. The spray paint sprays out in ultra-fine mists, adhering evenly to the surface. This electrostatic paint creates excellent chemical adhesion before being dried to restore the shell's structure. Now comes the stage of electronic diagnosis using a multimeter, setting the resistance scale to check for continuity. The expert probes for every shorted or burnt SMD component. The electrical feedback signals indicate the damage is far too severe. The LCD screen continuously displays incorrect parameters. Oxidation has completely destroyed the multi-layered printed circuit board. Restoring the original motherboard is impossible. Instead, a brand new central charging motherboard is taken out. The gold-plated contacts are shiny. The micro-soldering pulse iron is activated, bonding the pairing button assembly at the exact coordinates. 4 deep solder joints are shiny, ensuring accurate physical signals. Moving on to the perfectly painted and dried charging case shell. The central motherboard is gently pressed into the positioning latches on the polycarbonate plastic frame, fitting perfectly to the millimeter. The technician skillfully applies solder to the poles. Each strand of the ultra-thin copper core power wire is quickly soldered. Fast soldering prevents heat spread from destroying the microchip. The system is powered by a brand new lithium-ion battery cell. The 2 electrical poles are tightly connected and insulated. The battery sits neatly in the compartment behind the plastic frame. Tweezers are used to gently reroute the optical flex cable, transmitting light from the status LED to the outside of the charging case. The 2 outer shell pieces are slowly closed, enclosing the entire complex mechatronic structure inside the case. Just enough finger pressure snaps the plastic latches into place, creating a perfect seal. The metal hinge is also securely installed. The charging case is now complete. Now it's time to resurrect the 2 earbuds. The main power component is the ultra-small button cell battery. To avoid the risk of short circuits in the tight space, the expert wraps the battery body with a layer of insulating Kapton tape. The two main Bluetooth microchips of the earbuds are placed on the clamp. The two poles of the button battery are carefully soldered in parallel. Intense concentration is shown in every movement of the soldering iron. The component block is skillfully threaded into the acoustic chamber of the fragile plastic shell. Continuing to solder the signal wires of the beamforming microphone assembly down to the bottom contact stem of the AirPods. The high-temperature soldering iron fine-tunes each joint. The custom driver speaker assembly is placed into the acoustic chamber. A technician works with micro-tweezers, fixing the biological diaphragm into the designated slot. Tiny solder points connect the voice coil to the digital audio processing board. The entire core module, including the battery and Bluetooth chip, is carefully pressed into the curved plastic shell. 4 layers of black acoustic mesh are attached to the surface. Precise pressure ensures the glue seals tightly. The two hemispheres of the earbud are joined together. The plastic latches fit perfectly, leaving no gaps. Sharp tweezers clamp the protective mesh of the beamforming microphone, pressing it firmly into the slot at the bottom of the earbud stem. This complex process is repeated precisely, with the right earbud syncing all microchips. The directional audio mesh is installed. The outermost shell is polished with a microfiber cloth. The original aerodynamic shape has returned. Placing the two earbuds into the magnetic chamber of the charging case. A magnetic pull draws the earbuds right onto the contact pins. Plugging in the lightning cable activates the charging current. Bringing an iPhone close, the Bluetooth chip algorithm recognizes the device instantly. The pairing window appears. The interface shows a full battery charge. The communication of wireless data works perfectly with no latency. Putting the earbuds into the ears, the skin detect sensor activates. Opening a test video to check the sound. The diaphragm vibrates, reproducing audio details. The spatial audio simulation function works excellently. Removing the earbuds disconnects the sensor. A close-up shot shows off the beauty of the device after restoration. From a rusted mud-caked block of scrap, the AirPods 3 have miraculously revived with absolute perfection.